What's up, everybody? This is Mr. Tui, creator of the SAT Crash Course series. And if you're looking for help with the digital SAT math test, I've got you covered. In this video, I'm going to teach you the easiest and fastest way to solve questions from the math section of Digital SAT Practice Test 1, Module 1. And if you like this video, make sure to like and subscribe down below, and be on the lookout for more digital SAT videos coming out soon. In the meantime, enjoy these answer explanations from Digital SAT Practice Test 1, Math Module 1. All right, welcome everybody to Digital SAT Practice Test 1. This is Module 1, and we're just going over some questions and some answer explanations from the most recently released Digital SAT Practice Tests. We're starting with Practice Test 1 and Module 1. We've got Tanner with us today. Say hello to everybody, please, Tanner.
Hi.
All right, thanks, Tanner. Appreciate it. And let's just jump into the questions. We're going to kind of go one by one, just go through these and really develop a full understanding of these questions here. So go ahead and read question number 1 for us, please, Tanner.
What is 10% of 470?
Yeah, so a lot of students can kind of just look at this and be like, "Oh, come on, I know how to find the answer. I know how to calculate this," or like it's just kind of obvious. Did you have to use your calculator here for this, or was the right answer kind of obvious to you, Tanner?
That was kind of obvious.
Yeah, and it's funny, right? I want to point this out. I actually do want to go. I want to go to my rules document here, my rules for SAT mathing here for the digital SAT, recently updated for the digital test. Let's go to that real quick. I actually want to read through. We're going to read through the first 3 rules here of this test, and I think rule number 2 really applies in this question. But let's read through these together. Start with rule number 1 for us, please, Tanner.
Avoid algebra whenever possible. Instead, plug in values for variables and solve.
Yeah, you're going to be surprised. There's a lot of questions where you don't have to carry out a specific algebraic operation. You can kind of just plug in values either from the answer choices or values of your own creation. We're going to play with that strategy a lot on this test. It's probably the most useful and powerful strategy I can teach you for the SAT, and it applies to the digital SAT as well. But really, rule number 2, I think, applies on this question. Go ahead and read rule number 2 for us, please.
Eliminate incorrect answer choices based on basic logic. For word problems, remember that you are dealing with real-world problems and real-world solutions.
Yeah, you can use a lot of logic on this test, and that's certainly the case with this question here. I do want to go back to the question, actually. That's up here on the whiteboard. You don't even have to calculate it. Now, don't get me wrong. You've got the calculator on the every math section of the digital SAT, so you can calculate if you want to. But like 10% of 470, it's not a lot, right? It's a relatively small amount. Is that pretty clear?
Yeah.
Yeah, it's just a small fraction of it. So like right off the bat, what answer choices can you get rid of right off the bat?
37.
Yeah.
423.
Yeah.
And
yeah, they don't make a ton of sense. But especially the big ones here, this 423 and 460, right, are kind of crazy. That's not 10% of 470. Now, to calculate 10% of 470, do you know how to do that, Tanner?
Yeah.
How do you do that? Can you describe it to me?
You can multiply 470 by 0.10.
Exactly, yeah.
Or divide it by...
Yeah. And let me make it really clear to anybody watching the recording here. 10%, we can describe that as a decimal, right? And I think you said you can describe it as what?
0.10.
Yeah, 0.10 or 0.1, 0.10, all the same. And the reason for that is that 10% literally means 10 divided by 100. Percent means out of 100. So you can just punch that in your calculator. Again, you've got that all the way through the digital SAT. If you divide 10 by 100, you'll get 0.1 or 0.10. So if you want to find 10% of any number, just multiply that number by 0.10. If you want to find 15% of any number, just multiply it by 0.15. If you want to find 20% of any number, just multiply it by 0.2. If you want to find 25% of any number, just multiply by 0.25. Does that make sense, Tanner?
Yes.
Yeah, and if you punch that in your calculator, you do indeed get answer choice B, the only one that's left. Any questions about question number 1?
No.
Okay, pretty straightforward. Nice and easy. They start off with some easier questions on the digital SAT. It's the same as the old SAT, really. They start with easier questions. But on the digital version of the test, they sort of slowly and gradually ramp up the difficulty level. So we'll see some tougher ones kind of popping up here. Let's just go to the second question. You should see that pop up here on the whiteboard. Go ahead and read question number 2 for us, please.
4x plus 6 equals 18. Which equation has the same solution as the given equation?
Yeah, what are we solving for here, Tanner, in this question? Let's make it really clear. Well, we're not just solving for x. We're going to have to. But they're not asking us for x. What are they asking us here?
Which solution has the is the given as the same whatever the equation? Which equation has the same solution?
Yeah, which equation has the same solution, right?
Yeah.
And so we're going to find out what x is here, right? We got a couple options here to find that.
Yeah.
Once we know what x is, we just plug that same value for x into the answer choices, and the right answer choice has to give us a true statement for that value. Does that make sense why that's going to work?
Yeah.
Okay, good. So just looking at this equation here, do you know how to solve for x here? I work with a lot of students that struggle with isolating variables here, but if we're going to solve for x algebraically, do you know how to do that?
Yeah, I do.
Yeah. Before we do that, I want to point out something else here as well, because my first rule is avoid algebra whenever possible. I just want to point out that even if you don't know how to solve for x algebraically, and again, many students don't, there's a way to just plug in values for x and find out what works. Does that make sense?
Yeah.
Yeah. And you can just kind of play with numbers here. It's probably going to be a whole number value. Do you think you could kind of just look at this like logically and figure out what x has to be?
Yeah.
What does x have to be here?
3.
Yeah, it's got to be 3, right? Isn't that funny that you can just kind of find the right answer even without doing an operation much of the time? Not every time, but much of the time. I just want to point that out. Then you can just kind of play with the numbers, be like, does 1 work? Does 2 work? Does 3 work? Oh, 3 works. There we go. Okay, great. Right? And kind of work your way up until you find 18 on the left-hand side of the equation. So 3 is the solution. Let's talk about solving this sort of algebraically, though. If you're going to solve this algebraically, could you show me kind of the step-by-step process, how you do that here on the whiteboard?
Yeah.
I know Tanner's just learning how to use the whiteboard here, but I think you're going to figure it out. Literally just press that draw button.
Yeah.
And just find a clear spot on the whiteboard.
So 4x weird x plus 6 equals 18.
Yeah.
First thing you want to do is isolate. Well, we can get rid of the 6.
Yeah.
Sorry.
Yeah.
Right off the bat.
Yeah.
And minus that from both sides.
Yeah, and as long as you just make sure you're following the golden rule of algebra, you're doing a great job here. Whatever you do to one side of the equation, you do to the other side of the equation. This is beautiful, Tanner.
Yeah. And then figure out what that would be, which would be 12. And then got to isolate x. So divide both sides by 4.
You got it. This is perfect, Tanner.
And then x equals 3.
Love it. Absolutely. Great. So that works too. You can solve for it algebraically. But just notice that we also solve for that just kind of like logically as well, which I'd expect to see on some of the earlier questions on the test, and that's the case here. But we haven't found the right answer yet. What do we have to do to find the right answer, Tanner? Now that we know x is 3.
Gotta check our answer.
Yeah. Yeah. Just got to plug that in, right, into the answer choices here. Start with the answer choice A. You don't have to, you don't have to work this out right here on the whiteboard. Don't worry about it. Use that calculator, man, right? So 4 times 3, is that going to work?
Yeah.
Is that going to give us a true statement for answer choice A?
No.
No, right? We get 12 on the left-hand side, so it's not A. Yeah, absolutely. You're rocking and rolling. Answer choice B, true statement?
No.
No, definitely not. What about answer choice C?
No.
Hold on. I would check that on the calculator when x is 3. What's 4 times 3?
Oh, right.
Yeah,
okay.
Right. That does give us a true statement, right? That's probably the right answer. Let's double check with D here. Does D give us a true statement?
No.
No. We're 12 equals 3. That's crazy. So we can confirm it is indeed answer choice C. Any questions about that, Tanner?
No.
Okay. Great job there. Let's keep it rolling. All right. I'm going to increase the size of this here a little bit. There we go. Okay, go to read question number 3 for us, please.
The total cost in dollars to rent a surfboard consists of a $25 service fee and a $10 per hour rental fee. A person rents a surfboard for 2 hours and it intends to spend a maximum of $75 to rent the surfboard, which inequality represents the situation.
Oh, interesting. What are we solving for here with this question, Tanner?
We are solving for the T for the hours or the time spent?
Well, we could, but the question's a little bit more specific. Now, let me point this out real quick. The thing you're solving for is always in the last sentence of every question. Okay? I think that's helpful to pay attention to on word problems. There's a lot of words. Like, what am I doing here? We're solving for the inequality that represents the situation described in the question. That's a pretty involved situation here. We're renting some surfboard. There's a $25 service fee and a $10 per hour rental fee. Okay. And then this person's renting the surfboard for T hours. So we've got to sort of develop the inequality that represents that situation. Does that question make some more sense?
Yeah.
Okay. Now, you can create the inequality. That's one option if you really understand how to set up an equation or how to set up an inequality. I mean, do you think you would feel comfortable developing this inequality sort of based on the information in the question, or not so much?
Yeah, I think I'd be able to.
Yeah. How would you do it? Let's talk me through it here.
Well, since we have the $10 per hour and we aren't given the specific hours.
Yeah.
Right off the bat, you can say that it's going to be 10 T.
Yeah, that's going to be the cost per hour, right? Absolutely. I love it.
And then you're going to have to, of course, add the rental fee, the service fee.
Uh-huh.
And then it has to be.
Yeah. Now, and this is a little tricky here. It wants to spend a maximum of 75.
Yeah.
Yes. So that cost is going to be less than or equal to 75.
Yeah.
You got what's the answer, man? What's the answer?
D.
It's absolutely D. Any questions about that?
No.
There's another way to do it too. Some students really struggle sort of developing equations or developing inequalities. It's not always easy. It's not always sort of obvious. You navigate it really beautifully there. I love it. Another way to do it is kind of figure out like what your maximum cost here is for T hours. You can kind of do it logically. Do you have any idea if he's trying to spend a maximum of $75? What's the maximum number of hours he could rent the surfboard for? Do you think maybe just logically, or maybe you can calculate it pretty easily? Do you have any idea?
7.5 hours.
Well, 7.5 hours won't do it, because if it's 7.5 hours, then the rental fee would be $75, but you're sort of ignoring that 25.
Right.
Yeah, right. There's that $25 service fee that you got to take into account as well. So what would the maximum number of hours be?
I want to say around 3 or 4. The service.
So if it's 3, right, and we can calculate, right? If it's 3 hours, then we've got like the rental fee would be $30, right? Because it's 3 times 10.
Yeah.
Plus 55. So I mean that would work. 3 hours would work, but that's not the maximum, because then it would be 30 plus 25, which is 55. Does that make sense?
Yeah.
You could even do more than 4 hours, because 4 hours would be 40 plus 25. That's $65. Does that make sense?
Yeah.
Yeah. So what's the maximum going to be?
5.
The maximum is going to be 5. Yeah. So T's got to be less than or equal to 5. The maximum is 5. Does that make some sense?
Yeah.
Yeah. So, you should be able to like plug in like a 5 for T into the answer choices, and the right answer choice should give you a true statement. The right answer choice should probably give you 75 on the left-hand side, because the maximum cost is 75. Does that make some sense? Why this would work as well? Yeah. If you plugged in a 5 for T into answer choice A, would you get a 75 on the left-hand side?
Mm-hmm.
What would that give you on the left-hand side?
On the left-hand side, it would give you 50.
It'd give you 50, right? So that's probably not right. What about answer choice B? Would that give you a 75 on the left-hand side?
No.
No, that wouldn't do it. It would give you something much bigger. So that's not a true statement. What about answer choice C?
No.
No, also too big on the left-hand side. What about answer choice D?
Yes.
That works. That's another way to do it. It's kind of develop values for T. And that's kind of following that first rule, right? Plugging in values in place of the variables. You got to be careful, because if you plug in like a 1 or a 2, I think a lot of the answer choices would give you a true statement. But if you plug in that maximum value, the right answer's got to be true, but you can get rid of the wrong answer choices doing it that way as well. Does that make some sense, Tanner?
Yeah.
You've got a lot of options here on these questions. But I think the more ways you can look at the questions, just the higher chances are of finding the right answer. So I like that second strategy as well. All right. Let's do the next one. Now, I've just started kind of working my way through these practice tests, so some of these questions are kind of new to me. Very similar to the old sort of SAT style questions. Really not a big difference in the concepts. A couple new things. But here we got a question on functions. Go ahead and read question number 4 for us, please.
The function g is defined by g multiplied by x equals x to the second power plus 9.
I'm going to stop you real quick, Tanner, because that you made a common error. A lot of students misinterpret this here. That g and then the parentheses x. A lot of students do interpret that as g times x, but that's not quite what it means. I would read that as g of x. G of x. We'll talk about in more detail here what that means, but it doesn't mean g times x. Like g of x is a value. It's a value. It's not g is a value and x is a value multiplied together. G of x is a value. So I'd read that as g of x equals x squared plus 9. Does that make some sense?
Yeah.
Have you seen functions before? I mean, you've come across those in your math classes yet?
Yeah, I have a little bit.
Yeah. Have you heard that phrasing before, g of x?
Yes,
yeah,
I have.
Okay, good. Yeah, that's how I'd read it. We'll talk about what that means here in just a moment. But go ahead and finish reading the question.
For which value of x is g of x equals 25?
Yeah. Okay, what are we solving for here? Tanner, let's make that real
We
quick.
are finding the value of x.
Yeah. Yeah. Here we are finding the value of x when g of x equals 25, okay? First, I want to step back a little bit and talk about functions and kind of what functions mean, okay? A lot of students get tripped up on this. I'm going to give you an example of a function. It's a different function from the one in the question, but I'm using this one just because it's a real simple function. I think it's going to make sense of kind of how functions work. Okay, and here's the function. We'll call it f of x equals 2x plus 1. It's a linear function. In fact, this would graph the exact same way on an xy axis as the equation y equals 2x plus 1. It would graph the exact same way as a line. Now, Tanner, if I said find f of 3, do you know what that means? Do you know how to find f of 3, how to calculate f of 3?
I think so.
Yeah, what does f of 3 equal? And you can say no if you don't quite know. That's okay.
My mind's kind of I can't remember.
Yeah, that's okay. Well, let's talk about it. So this is function notation. This is what it means. This means where there was an x in the function, now there's a 3 in the function. 3 is your input into the function. It's your input for x. Does that make some sense?
Yeah.
Yeah. By the way, if you need to move around the whiteboard, there's a little move button you can use to kind of scroll around without moving the question. Just if you need to, and you can zoom in and out using the options button. Just a heads up.
Yeah.
But yeah. So all that means where there was an x, now there's a 3. So let me see you rewrite the function, but in place of an x, plug in a 3. Let me see you do that on the whiteboard.
Just the f of x.
Yeah. Well, let's find f of 3. So I'd write f of 3, and then you're just rewriting the equation, but with a 3 in place of the x.
Oh,
you're not. Yeah, exactly right. You're replacing. Yes. Yeah. So that's 2 times 3 plus 1. Yeah. So what does that equal?
That equals 7.
Yeah. So you could literally say, and should, f of 3 equals 7. Okay.
Yeah.
And all that means is, again, where there was an x, now there's a 3. 3 is your input into the function, okay, for x. And then f of 3, or f of x, is your output for the function. That's what f of x means. Or in this case, with this question, that's what g of x means. It's your output for some input of x. Does that make some sense?
Yeah.
Okay. Also, I think I said earlier that this function would graph the exact same way y equals 2x plus 1 would graph. F of x and y are basically interchangeable. They are interchangeable. And so we could rewrite, this expression f of x or f of 3 equals 7. We could write that as an ordered pair on an xy axis. We could say the point 3, 7 lies on the graph of the function. That's to say when x is 3, the y value, or the f of x value, same thing, is 7. Does that make sense why that works?
Yeah.
Yeah. Really helpful to know. I don't know if you need to know that, certainly with graphing or anything like that on this question, but some other function questions, that does come up, and you really do need to have that understanding. I do want to go to the rules real quick, and I want to point this out. I do have a section here on functions that's worth checking out. So let's check out the rules. And this is basic concept A, functions. It's one of the most commonly tested concepts on the SAT. Do you have that rules document in front of you at the moment?
Yeah.
Okay. I want you to read that first bullet point on functions. Go ahead and read that first bullet point, please.
Understand x is the input, f of x is the output. Also understand f of x as fancy y.
Yep, they're interchangeable when graphing on the xy axis. Does that make some sense now? That bullet point about functions.
Yeah.
Okay, great. All right. So let's go back to the question because we haven't really answered the question yet. Okay, so the question is, for which value of x does g of x equal 25? Okay, that's the question. Do you see how we can kind of test these answer choices here? Really, it's kind of like a plugging in values question. Do you see how we can test these to find which value of x equals, does g of x equal 25? How can we test that?
Plugging in the answer choices in for x.
Yeah, absolutely. That's all we're doing here. We're just plugging in. So let me see you do that on the whiteboard. We'll start with answer choice A. We'll see if 4 makes g of x equal 25. Absolutely. You're just plugging in for x.
16. That's not.
Does that equal 25?
Yes.
Sure does. I think we found our answer.
I think so too.
It's answer choice A. It is. You could test the others, but there's no need to here. I think, if A gives us a true statement, the others aren't going to be right. Answer choice B would give us 25 plus 9, 30, 34. The others are going to be way too big. But once you understand what function notation means, it's really easy to find the right answer. Does that make some sense?
Yeah.
Yeah. You could also, there's another way to do it too. You could plug in 25 for g of x and sort of solve this algebraically. You could plug it in like this: 25 equals x squared plus 9. And then sort of like you'd have to subtract 25 on both sides and do some factoring. You could do all that. But I think that's really, we're kind of following rule number 1 of like, plug in the values for the variables, man. If you've got that option, and that's an option here, it's just a much easier path, and you don't have to mess with factoring. Everybody screws it up. And I do too sometimes. So plug in the values when you've got the option. Does that make some sense?
Yeah.
Okay. You're doing great, man. This is good. Let's do the next question. All right. Go ahead and read question number 5 for us, please.
Each face of a fair 14-sided die is labeled with a number from 1 through 14, with a different number appearing on each face. If the die is rolled one time, what is the probability of rolling it 2?
Ooh, what are we solving for here, Tanner?
We are solving for a probability for a 2, which could be a percent, a fraction, a decimal.
Yeah. Are you familiar with probabilities? I mean, like, do you know how to solve this?
Yeah. I've done a few probabilities.
Good. Let's kind of talk about probability in general real quick before we solve this specific question. There's a formula for probability. I just want to explain this to anybody watching the recording. There's a formula for probability you need to know. And that formula is this. And my handwriting is just wretched. I really apologize. But probability... And my spelling is not great either. There we go. Probability equals the winning outcome, or the winners. I like to describe it as winners. Your winning outcome, the outcome you're looking for, divided by the total number of possible outcomes. Have you ever heard that before? Are you familiar with that formula for probability?
Yeah.
Yeah, okay. That's also on my basic concept cheat sheet. I'm just going to go to it real quick. I think it's basic concept M. There it is. The same formula. Probability equals winners divided by total number of possible outcomes. Again, all the basic concept that they test on are here on this cheat sheet. Okay. So in this case, all we got to do is we got to figure out what our total number of possible outcomes are. And we got a 14-sided die, which is kind of funky. But what's our total number of possible outcomes here?
14.
It's 14, man. That's our denominator. We know that right off the bat. I always recommend starting out with the denominator on a probability question. Start with the total number of possible outcomes, because then the winning outcomes that you're looking for are going to be taken from within that set of possible outcomes. The winning outcomes are going to be, it's 0 through 14. That's it, right? Where 0 would be no chance of it happening. Like that'd be the probability of rolling a 15 on a 14-sided die, not happening. And the highest probability would be 14 out of 14, which would be 100%. So that would be the probability of rolling a number 1 through 14 is 100%. Okay, so what is our winning outcome here?
1.
It's 1, right? And it's a little bit tempting here. Some students are gonna think that the winning outcome is 2 because they're like, oh, it's probably only a 2, so put a 2 in the numerator. No, 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 no. The question is, how many winning outcomes are there? There's only 1, 2 on a 14-sided die. So we only have 1 winning outcome. So pay close attention to that. Some students are going to be tempted by answer choice B here. But what's the answer?
1A.
Yeah, A. Yeah, you got it, man. You got it. And that's, I mean, you know, if you just understand how probability works, like that's a real straightforward question. I think you got a handle on it. Any questions about that?
Nope.
Okay, great job. All right. Let's try question number 6. Go and read question number 6 for us, please. You see it on the screen.
A printer produces posters at a constant rate of 42 posters per minute. At what rate in posters per hour does the printer produce the posters?
All right, what are we solving for here, Tanner?
The rate at which it's doing posters per hour.
Per hour, yeah, posters per hour. Yeah, and we know the rate per minute here.
Mm-hmm.
We've got some options. You know, we could think in terms of like unit conversions, potentially. There's a way to do that. I think this is much easier, sort of following that second rule, using like basic logic and common sense instead of like doing a fancy operation here. Just like you can logic your way through this and figure out how many posters this printer is producing per hour. You know what I'm saying? Like you can logically figure it out, because if it's producing 42 posters per minute, you know how many posters this printer is producing in 2 minutes, right? How many is it producing in 2 minutes?
In 2 minutes, it's producing 804 posters.
In 2 minutes?
Yeah.
Well, if it's producing 42 posters in 1 minute, think about that. In 2 minutes. Yeah, probably closer to 84. Does that make sense?
Yeah.
Yeah. So we're just multiplying 42 times 2 to find out how many posters it's producing in 2 minutes. What about in 3 minutes? You can use your calculator here. I probably would. How many posters is this printer producing in 3 minutes?
126.
Yeah, because it's just 42 times 3. Does that make sense?
Yeah.
And then in 10 minutes, it would be like 420. In 10 minutes, you're just like multiplying the posters per minute by the minutes. Do you see the operation now?
Yeah.
Yeah. So what do we have to do to find out how many posters this printer is producing in an hour? What's the operation?
42 multiplied by 60.
Exactly, because there's 60 minutes in an hour. That's it. What's the answer, by the way? I'm going to have to punch that into the calculator. I don't know the answer without a calculator.
1,520.
Yeah. And that's the answer. Notice this is a write-in question here. There's no, it's not multiple choice. You have to write in the right answer. This is one of the differences between the digital SAT and the old one, is that the write-ins were reserved sort of for the end of the math sections on the old SAT. On the digital SAT, they've got some of the write-ins a little bit earlier on. This is one of them. But I recommend kind of logicking your way through this before you just start doing an operation. Just like, okay, what's going on here? What does this all mean? And start there. So nothing too fancy here. But that's the right answer. Any questions about that one? That rate question?
No.
Okay, great job. We're zipping through this, kind of. We're on question number 7 now. Ooh, looks like another function question here. Go and read question number 7 for us, please.
The function f is defined by the equation f of x equals 7x plus 2. What is the value of f of x when x equals 4?
I think you know exactly how to solve this now, Tanner, now that we've discussed functions in depth. How can we... Well, what are we solving for here?
We are finding the value of f of x by using x equals 4 in the other side.
Yeah. What you might be able to tell me right now what the right answer is. I mean, you can calculate it using your calculator or work it out here as well.
We'll do it right here.
Yeah.
4.
Yeah, you're just plugging in a 4 for x. That's all you're doing.
2. And that's going to be 1 second.
Yeah, use that calculator. Don't hesitate, man. You've got the calculator all the way through the
28
test.
plus 2
Yeah.
is 30.
Yeah. Bam.
And that is going to equal f of x.
Yes. There's your answer. It's 30. Any questions about that, Tanner?
No.
Really easy if you understand what function notation means. Really easy. You're just plugging those values. Now, would you have been able to do this maybe before we started our work today, before we kind of discussed functions, or would it have just been kind of confusing?
I don't think I would have been able to really solve it.
Isn't that funny, right? Like just knowing the concept, sort of knowing what this language of function notation means, the operation's really obvious. Yeah, you're just plugging in 4 for x into the function. That's it. Great job there, Tanner. All right, let's keep rolling. We got some tougher questions coming up. If you're kind of watching this recording and you're like, oh, I can do all these. Well, we'll see what happens when we get a little bit later in the test. It does get a little bit trickier. Go and read question number 8 for us, please.
A teacher is creating an assignment worth 70 points. The assignment will consist of questions worth 1 point and questions worth 3 points. Which equation represents this situation where x represents the number of 1-point questions and y represents the number of 3-point questions?
Ooh, what are we solving for here, Tanner?
We are solving for an equation representing the number of 1-point and 3-point questions using x and y.
Yep, exactly. Do you think you know how to structure this equation?
Yeah.
Okay. How would we do it?
You would be taking 1 second.
You gotta really, take your time understanding. You gotta really understand the scenario, and that's the key, right? Don't just start doing stuff. Really understand the situation here.
3 points. 3 points. Yeah. So we could say that we know already that we have x point questions, which is an unknown number, plus the y, which is the 3-point questions.
Yeah.
And that's ultimately going to equal 70. Oof, we can even go over here and take more on that 70.
Yeah.
Now,
I'm not saying, I'm looking at the answer choice here. I don't see the equation that you structured here. Right?
Yeah. I'm thinking one of the 4, with the 4s in it's going to be one of the answers. I'm leaning more towards B.
Yeah. Let's do this, Tanner. I want to apply that first rule of avoiding algebra whenever possible, and instead plugging in values in place of the variables, because we can do that here. Okay, I don't think it's A. I don't even think it's B. I'm not certain. I don't have the answer key in front of me right now, but I don't think that's it. I want to create values for x and y. Okay, but I don't want to just create any values. I want to create values such that we're going to get a total number of points that are worth 70 points. Does that make sense?
Yeah.
Okay. Here's what I'm thinking. And I'm just going to keep this real simple just to start testing answer choices. I'm going to make x, that's the 1-point questions. I'm going to make x equal 70. Okay?
Yeah.
Which would give us 70 points. Is that clear, right? Because the x represents the number of 1-point questions.
Yeah.
Right? So we're at 70 points already. So if x is 70, what's the y value? If x is 70. You don't have to use an equation or anything like that. Right? If you've got 70 1-point questions and the assignment's worth 70 points, you should know how many 3-point questions we have, just logically.
0? Or would it be?
Yeah, 0. Yeah. We don't have any, right? Because we're already at 70 points. Does that make sense? Why?
Yeah.
The right answer should give us a true statement. When x is 70, y should be 0. Does that make sense?
Yeah.
Okay. Now we can take those values and plug those into the answer choices. The right answer has to give us a true statement for those values. And the wrong answers probably won't. Does that make sense? Look at answer choice A. Is that going to give us a true statement for these values?
No.
No. What do we get on the left-hand side for answer choice A?
We'll get 0.
We'll get 0 on the left-hand side, right? Because y is 0. Anything times 0 is 0. Whole left-hand side is 0. Not a true statement for answer choice A. Gone. What about answer choice B? Is that going to give us a true statement for these values?
No.
No, we're going to get 4 times 70. I think that's 280, but just not a true statement for those values. It's not A or B. What about answer choice C?
No.
No, I think it gives us 210 plus 0, right?
Yeah.
It's 210. I sure hope D works. Let's try D. Does that give us a true statement for these values?
Yeah.
It's the only one that does. And I got news for you. It's answer choice D. Does that path of plugging in the values for the variables make sense, Tanner?
Yeah.
It's my favorite strategy for the SAT. It works on so many questions, man. And even if you think you've got a path algebraically, it's just really easy to sort of misinterpret or just not set things up properly with the algebra. Now, I do want to talk about the algebra as well, okay, because I want to make that really clear. So let's think about this sort of algebraically. So if X is the number of one-point questions, you could represent the points from the one-point questions as 1 times X. Does that make sense?
Yeah.
Okay. And then the number of 3-point questions is Y, and you could represent the points from the 3-point questions as 3 times Y, because for each 3-point question, just multiply that by 3, you'll get the points from the 3-point questions. Does that make sense why 3Y represents the points from the 3-point questions?
Yeah.
Yeah. And then if you add all that up, you should get 70 because the total number of points for the assignment is 70. Does that make sense?
Yeah.
Okay. Okay. Now, we don't see this exact equation in the answer choices here, but it's darn close to D. Do you see that? It's darn close.
Yeah. But
And
1x.
1x is the same as x.
Yeah.
Because 1 times x is just x. That's really the only difference there.
Mm-hmm.
But if you can, if you can set it up, great. Some students can look at this question like, okay, I know exactly what to do, and they find a path, and that's fine. But if it's unclear at all, if you're uncertain at all, you've got this option of creating values that give you a true statement sort of in the scenario described in the question, just plugging those in and testing them. And that'll give us the answer. Questions about that, Tanner?
No.
Okay. Getting a little trickier here. I have no idea what this question is. Let's see. I was working these out a few days ago. Oh, we got some geometry going on. Geometry. Have you taken geometry yet, Tanner?
Yeah, a little bit.
A little bit. Okay. All right. Go to question 9. We'll talk about solving this one together, and I'll guide you through it. Do you see the question up on the screen?
Yeah. I just loaded up.
Okay. Go ahead and read it for us, please.
Right triangles LMN and PQR are similar, where L and M correspond to P and Q,
respectively. Yeah, it just means in that respective order.
Respectively. Angle M has a measure of 53 degrees. What is the measure of angle Q?
Yikes! What are we solving for here, Tanner?
We are finding the measurement of angle Q by using angle M.
Yeah, we're finding the measurement of angle Q, which corresponds, I guess, to angle M. Maybe we'll see here. So, okay, before we do anything here, we got to go to the rules. Because this is one of the big differences between the new digital SAT and the old SAT. In the old SAT, they were giving us a lot of figures. And on the new SAT, all the geometry questions I've seen, I'm still working through the practice test, but all of them I've seen so far, they're just describing the geometry question. So I want you to read rule number 3 for us, please, in my rules for SAT mathing.
3. For geometry problems, always draw a picture of the figures described in the question. You have to conceptualize the question the right way first before you can solve it.
Yeah, you got to draw a picture, man. They're not giving us figures anymore, not like they used to. And so we're going to have to draw these triangles, okay, I think before we try to solve for anything here. So let's draw. We've got 2 right triangles. You know what a right triangle is? Do you know what that means?
Yeah.
Yeah.
It has a 90-degree angle.
It's got a 90-degree angle. Absolutely, yeah. Great. So give me 2 triangles. You can make them basically the same. It says they're similar triangles, which, by the way, means they've got the angles are the same basically. The lengths may be different, but the angles are all the same. So I just make them basically the same looking kind of triangle. Yeah, you're doing a great job here. Okay, great. And then one of the triangles, just make the one on the left, make that LMN, and we'll make the one on the right Pew. Pew's not a letter. PQR. Yeah. Yeah.
Angle M. M would be down here then. Or
yeah, no.
L.
See, that's exactly how I would. No, you're doing it the right way. I would make this angle here at the bottom. Yeah, this is exactly how I do it. And the reason why, when I did it first, I made this angle M, but I'm like, they tell us what M is. Angle M is 53 degrees, and that's the 90-degree angle there.
Yeah.
On the right triangle. So I like where you put M, sort of in the bottom right corner. I'm going to label that angle M as well. You're doing great. Angle M is 53 degrees.
Mm-hmm.
Okay, they tell us that. So we should know, by the way, I want to make sure. So LM corresponds to PQ. That's perfect, right? Because here's... Does that make sense why that works out beautifully? LM corresponds to PQ. This is absolutely perfect.
Yeah.
Does that make sense? Okay. So I think we know angle Q as well, right? What's angle Q if these are similar triangles, which they are?
53.
It's also 53 degrees. Does that make sense?
Yeah.
Okay. And we're trying to find the measure of angle Q. Oh, boy. And this would be trickier if they were asking us for the measure of angle P. There's a way to do that. But I think we know the right answer, don't we?
Yeah.
What's the right answer?
53.
It's got to be 53. Yeah, I'm going to double check here, but yeah, it is answer choice P, 53. That's not bad, is it?
No.
If you can draw a picture. If you can draw a picture, that matches the description of the scenario in the question. It's just not bad. That's pretty obvious. Q's got to be 53 degrees. Now, if they asked for angle P, would you know how to solve for angle P if they asked for angle P? This guy.
It's been a while since I
just remember, just because, you could see a question like this, where they ask for that unknown angle.
Yeah.
Every triangle has how many degrees?
3 different angles or degrees.
Well, but how many degrees total in a triangle? Do you know? How many?
Oh,
I don't know.
75?
No, each triangle has 180 degrees in a triangle.
Yeah.
180 degrees. So if you subtract the two known angles from 180 degrees, so we could subtract 90 and 53, that would give us the remaining unknown angle, P here. Does that make some sense why that would work?
Yeah.
I just want to point that out. You don't need that here for this question. That's kind of how it works. And I've seen some questions like that on the SAT where you got to solve for the unknown remaining sort of angle. What would that be, by the way? Oh, there you go. Yeah.
37.
37, yeah, if they ask for that. But that's answer choice A, right? Which you could get if you don't quite draw the triangles correctly as described in the question. So take your time really processing the question and drawing an accurate picture. You'll find the right answer, no problem. Any questions?
No.
Okay, great job. Let's keep it rolling. Question number 10. Ooh, might be doing some algebra here. Go and read question number 10 for us, please.
The solution to, might as well start with the equation y equals minus 3 multiplied by x, 4 multiplied by x plus y equals 15. The solution to the given system is equation is x and y. What is the value of x?
What are we solving for here, Tanner?
X.
Yeah, we're solving for x. We got a little system of equations here. Have you solved systems of equations before, Tanner? Are you familiar with that process of solving for systems of equations? Or not so much?
Give me 1 second. Writing it out.
You've got a couple options here with systems of equations. First, there is a way to plug in values here. We can test these answers. There's a way to do it.
Yeah, they give us y already.
Well, they give us y. Oh, they give us y here in the top equation, right? Is that what you're talking about?
Yeah.
Here? Yeah, absolutely right. So yeah, there's two methods. One is called the elimination method, and the other one is the substitution method. Most of the time on the questions I've seen, certainly on the old SAT, like 90% of the time, elimination is your best bet. But here, this is set up beautifully for substitution, if you're familiar with that. Does that make sense? Yeah.
Yeah.
Because we can literally just plug in negative 3x for the y in the bottom equation.
Yeah.
Right? Now don't forget that's 4x, right? Don't forget that
Yeah.
that x, right?
I'm leaving it blank
Okay.
to
Yeah.
and substitute in for x with the numbers.
Gotcha.
Right?
Oh, I love it. I love it. I see what you're doing. This is good. This is good. This is good. Yeah.
So one wouldn't work right off the
One's not
bat.
going to work.
I know that.
Yeah.
4 and 5.
Yeah. I just want to explain to anybody watching the recording what Tanner's doing here. He's setting this up and then plugging in the answer choice here for the x values and seeing what gives him a true statement. I love it.
20 plus negative 15.
Yeah. It's going to just be 20 minus 15.
Yeah, 20 minus 15 is 5. So that wouldn't work
That doesn't
either.
We're looking for 15. Let's try answer choice C. I'm going to clear some space here for it. Yeah. Oh, I think I erased. Hold on. Let me take you back to what you're doing here. There we go. Just erase the 5s. Yep.
Yeah. So 5 wouldn't work. Then we have 15 as an option. 4 multiplied by 15 is...
Use that calculator if you want to.
Yeah. So I'm doing 15. 60.
60.
And then negative 3 would be negative 75.
Ooh, punch that in the calculator. Double check on that, Tanner. Double check that arithmetic.
Oh, what?
3 times 15.
45.
45.
Wow. Change that.
3 times 25, right, would be 75. Yeah.
Yeah.
And that gives us a true statement.
60 minus 5. It's 15.
That works. I think we got our answer. It is C. Absolutely. Absolutely. I like what you did there. You kind of a combination there of thinking in algebraic terms, substituting negative 3x for y, and then just kind of testing the answers. I think that as long as you can keep your arithmetic straight, which you shouldn't have trouble with again, because you just use that calculator all the way through, you'll find the right answer. That's nice. I do want to talk about the algebraic operations here, though, as well, right? Because if you're doing the algebraic operations, it's actually pretty straightforward if you kind of deal with these equations in terms of x. Because we can rewrite the bottom equation as 4x minus 3x. Does that make sense why we can replace that y with a negative 3x? Is that clear?
Yeah.
Yeah. Equals 15. And then we're actually really close to finding the right answer because what's 4x minus 3x?
1x.
It's 1x. Yeah, which is just x. And there's your answer right there. X is 15. Booyah. Does that make sense? Why you can do it sort of algebraically? Yeah. That's really not bad. That'll actually save you quite a few steps.
Yeah.
If you do the algebra. So I'm not opposed to using algebra, good heavens. But if the algebraic path isn't clear, and again, I work with a lot of students that struggle sort of just making kind of silly errors with algebra, and I do too. The more steps I'm doing, the more, I think it's true with anybody, the more likely you are to make silly mistakes. So if you limit your operations by turning to arithmetic, that's great. Here it's actually fewer operations doing the algebra. They kind of set up nicely to solve for x algebraically. So that's a good path too. Questions about that, or does that make sense?
That makes sense.
Good. You're doing great. Doing great. Let's keep rolling. All right, question number 11. Ooh, this is an ugly looking question. Go and read question number 11 for us.
Which of the following equations is the most appropriate linear model for the data shown in the scatter plot?
Yeah. Have you seen scatter plots before? Do you understand sort of what that term means?
Yeah.
So they're not giving us a line here exactly, they're just giving us a bunch of points. But like you can kind of connect the dots and really pretty much there's a line there. Do you see the line essentially?
Yeah.
Maybe it's not a bad idea, honestly, to draw that line. In fact, I'm going to do that real quick here on the whiteboard, sort of like follow that path of that line, roughly. Not perfect there, but close enough. Now, do you know, Tanner? Do you know how to graph? Do you know how to graph equations here? Like, if you saw a line on x-y axis, do you know how to come up with the equation for that line, or not so much?
I did them for a while. I just need a refresher.
Yeah. Well, let's do it. Dude. If you look. I mean, if you struggle with it a little bit, then I guarantee you, there are people watching the recording, right? That also need that little refresher. So it's no problem at all. Let's talk about y equals mx plus b form a little bit.
Mm-hmm.
Let's talk about that. Okay. Y equals mx plus b. All right. Let's start with that that m value in y equals mx plus b. What does the m value in y equals mx plus b represent, Tanner?
A measurement.
Well, not really. M stands for the slope. The slope. Okay, you've heard that term before, right? Slope.
Yeah.
And there's a couple ways to think about slope. You can kind of think about it as a rate of change. That's helpful sometimes. There's another way to just calculate it, where slope equals basically the rise over the run. That is how much you're going up divided by how much you're going over on the xy axis. Is that somewhat familiar? You've seen that before?
Yeah.
Yeah. So we can calculate the slope. I don't think there's a need to here, but some questions where that might be helpful. So just be aware of that. Just see how much you're going up, how much you're going over, and you've got the slope. Let's talk about that b value in y equals mx plus b form. What does that b value represent? You can say, I don't know if you don't know. That's okay too.
I'm not sure if I remember.
Yeah. It's the y-intercept. The y-intercept. This is darn helpful to know on this question and a number of others on the SAT. That's the y-intercept. As I say, that's the point where the line hits the y-axis. That's your b value in y equals mx plus b form. Does that make some sense?
Yeah.
It shouldn't surprise you that number there, that term, is your y-intercept, because when x is 0, if x is 0, that's the point on the line when the line hits the y-axis. And we should be able to look at this graph here and say, okay, well, what is the y-intercept? It's a value. What is it? Where does the line hit the y-axis? What's the y value?
Around the top.
Yeah, it's at the top. So around what number? Yeah.
Around 10.
Around 10. That's your y-intercept. And that should make a ton of sense, again, because that's where the x value is 0 at that point. So all you're left with is that b value, that constant sort of at the end of the equation. So the line hits 10, or roughly 10. So let's take a look at the answer choices right now, because just thinking in terms of the y-intercept, that b value in y equals mx plus b form, you should be able to find, or at least start getting rid of some answer choices where the b value, the y-intercept, just isn't 10 or around 10. What answer choice can we get rid of right off the bat?
The b. All of them have a 10 in them.
Well, some have 10 and some have negative 10. Or 10.
Oh, right.
Yeah, do you see that now?
Yeah.
Yeah, you can get rid of C and you can get rid of A, because the y-intercept just isn't negative, let alone, 10. Or let alone negative 10, I should say. We can get rid of those right off the bat. Does that make sense?
Yeah.
Okay. Now, what's the difference between B and D? It is between B and D here. What's the difference between them?
B has a negative 1.9.
Yeah. B has a negative slope and D has the positive 1.9 slope. Now, if you know anything about graphing, you might be able to tell me, do you know whether this line is going to have a negative slope or a positive slope? Do you have any idea?
I think it's going to have a negative slope.
It's going to have a negative slope, absolutely. Yeah, because if it's going downhill from left to right, which it is, going downhill, that's going to be a negative slope. Because as the x value increases, the y value is going to decrease.
Yeah.
If the slope is negative. So absolutely, we can get the right answer. We got the right answer here, right? We didn't have to calculate the slope. Barely had to calculate the y-intercept. We just look at it and see what's reasonable. And that's good enough to get us the right answer here. Does that make sense?
Yeah.
Yeah. I want to go to the rules document as well, just to kind of show you where this is on the rules document. If you go to that, that's basic concept D, as in dog. That's for graphing. And I'm just going to read that second bullet point just to make this really, really clear.
Okay. For y equals mx plus b, m is slope, rise/run. B is the y-intercept.
Yeah. So at the very least, even if you're not super comfortable with graphing, I work with a lot of students that just don't quite know how to do it or aren't really comfortable with it. Look for that b value. That's the constant sort of at the end of the equation. That's your y-intercept. And just knowing the y-intercept here, where the line hits the y-axis, you can get rid of 2 of the bad answers and you got a really reasonable shot. And then just see if you got a positive slope or a negative slope here. It's just negative because it's going downhill left to right. So, questions about number 11?
Nope.
Okay, great. Let's try the next one here. There's 27 questions on each module here. We're working our way through. Ooh. All right, go ahead and read question number 12. This is a little bit terrifying looking. Go ahead and read it first, please.
The graph of y equals f of x is shown, where the function f is defined by f of x equals ax to the third power plus bx to the second power plus cx plus d. And a, b, c, and d are constants. For how many values of x does f of x equal 0?
Ooh, what are we solving for here, Tanner?
We are solving for how many of the values is f of x equals 0.
Well,
So,
how many values of x does
Yeah.
f of x equal 0? Does that make some sense?
Yeah.
Yeah, yeah. Ooh, so we were just talking about function notation a little bit earlier, right? And remember I said that that f of x and y are interchangeable. It's the same thing.
Mhm.
Does that make some sense? Yeah. And in case you were kind of confused about that, they remind us here. Y equals f of x. It's the same thing.
Mhm.
Okay? So really, like we could look at this question kind of in another way. We could say, okay, for how many values of x does y equal 0? Right? It's the same question.
Yeah.
Does that make sense why it's the same question?
Yeah.
Yeah. Well, hey, let's look at this graph of the function.
Mhm.
And I want you to help me out here. I want you to circle all the points on the graph where the y value equals 0. I want you to circle them.
Right there.
Well, that technically that is, but that's not on the
That's
graph.
zero.
That's not on the graph of the function, right? That's the origin, right? And the x-y axis is not on the function. So show me points on the function where y equals, although y is 0 at that point. That's not on the function. I don't
there?
think, hold on. That's where the x value is 0. Do you see that? That's where the x value is 0, right? We're getting our x's and y's mixed up a little bit here. Here's the y-axis, right? This guy going up and down right here,
Yeah.
right? That's the y-axis. But at that point, the y value isn't 0. That's the point 0, comma, -6. That's where the x value is 0 and the y value is -6 at that point. Does that make sense? Why? The y
Yeah.
value isn't 0 there.
Yeah.
Yeah, it's your
That'd be-
ordered pairs. It's got to be x, comma, y. Now we're talking. Take a look at those points. I want to make this really, really clear. I'm going to zoom in a little bit as well. Let's look at those points. This point right here, what point is that on the xy axis? Could you tell me?
-1.
Yes, that's the point -1, comma, 0. Where the x value is -1, the y value is 0. So that works. That's one of them. What's this point right here?
4,
4,
0.
comma, 0, exactly. Where the x value is 4, the y value, or the f of x value, same thing as 0. What's this point right here?
7, 0.
7, comma, 0, where the x value is 7, the y value is 0. What's the
Yeah.
right answer here, Tanner?
3, because we have 3 of the...
We've got 3 of those points
Value.
where, yes. So a couple things here. Again, there's not a fancy operation here, right? There's not a lot of steps or anything like that. It's just understanding what things mean here in the question.
Yeah.
And first, you just got to know that f of x and y means the same thing. And again, they remind us in case we forget that. And then the question's asking us, okay, so how many values of x does the f of x or the y value equal 0? Just find those values, find those points on the graph. In this case, we've got 3 values where f of x equals 0. Does that make some sense?
Yeah.
Yeah. By the way, if we needed to, we could develop the equation for this function, at least in a factored form. Do you know what I'm saying? I know we don't, we've got the answer here. We're good here. But on some other, I've seen a number of questions like this where basically if you know the x-intercepts of a function, that's what those points are. The x-intercepts of the function is where the y value is 0. If you know the x-intercepts, you know the factors of the function, Let me show you what the factors of the function are. So here's the function in factored form. It's f of x equals x plus 1 times x minus 4 times x minus 7. And the reason for that is that we know when you plug in a negative 1 for x, you have to get 0 for the y value or the f of x value. And if we plug it in there, we get 0 times a bunch of other stuff. That's going to be 0 for the f of x value. Does that make some sense?
Yeah.
Yeah. And if you plug in a 4 for x, and of course you're plugging into all those factors, but you're still going to get some factor times 0 times another factor. It's still going to be 0. So that's the x value that gives you a 0 for f of x, or another one. And then here's the last one. With that 7, you plug in a 7, then you also get 0 for f of x. So those are your 3 factors, and that's your equation. You know, you could multiply that if you wanted to, if you needed to. You don't have to for this question. It's just recognizing basically how many times the function crosses the x-axis. That's when y or f of x is 0. Any questions about that, Tanner?
No.
Okay. It's so the SAT, right? It's like it's not that heavy on operations on a lot of these questions. It's just understanding what things mean.
Yeah.
All right. Go on to read question number 13 for us, please.
Vivian bought party hats and cupcakes for $71. Each package of party hats costs $3, and each birthday cake costs $1. If Vivian bought 10 packages of party hats, how many cupcakes did she buy?
Ooh, what are we solving for here, Tanner?
We are solving for the number of cupcakes she bought.
Yeah, the number of cupcakes she bought. Again, the thing you're solving for is always sort of at the end of the question. That's the case here. There's a way to set this up algebraically. I think we can create a system of equations here. There's a way to do it. But I don't want to do that because it's just so easy to mess up systems of equations. I think we can do this logically. Because if she bought 10 packages of party hats, right, I think we can easily figure out how much 10 packages of party hats would cost. Right? Can't we figure that out pretty easily? Just like logically. How much would 10 packages of party hats cost? Could you tell me?
$30.
$30, because each party hat package costs $3. So it's just 10 times 3. Does that make sense why we know it's $30 so far? That's for the party hats. I'm just going to make a note of that with my really terrible handwriting. Party hats. Okay, great. And then the question is, how many cupcakes did she buy? How much does each cupcake cost, Tanner?
$1.
$1. And we need to get to a total of how much?
We have to get to a total of $41 because we subtract 71.
Yeah. So how many cupcakes did she buy?
41.
41. There's your answer. No variables, nothing fancy, no systems of equations to mess up, no algebraic operations to mess up, just logic. I mean, is there any doubt about this? I haven't looked at the answer key yet, but is there any doubt that we're talking about 41 cupcakes?
Yeah, it's going to be 41.
It's got to be 41. That's it. Let me double check here. Yeah, it's 41. Yeah. So look for ways to do that, to think in like logical terms here and turn these questions into arithmetic as much as you can. I think most of the time it's your best bet. This is real straightforward, real basic arithmetic. This is like a middle school math question. Does that make sense?
Yeah.
Yeah. If you're really comfortable with systems of equations and like you feel more comfortable, like I'm down with whatever works. But I think for the vast majority of students I work with, just turn this into logic and arithmetic as your best path. All right.
Yeah.
Great job. Let's look at the next one here. Ooh, go ahead and read question 14 for us, please.
Z to the second power plus 10 multiplied by Z minus 24 equals 0. What is one of the solutions to the given equation?
Ooh, what are we solving for here, Tanner?
We're solving for Z.
Basically solving for Z, right, which is going to be the solution.
Yeah.
One of the solutions. We're going to get multiple solutions here, really, for this equation. Couple ways to do this, Tanner. Again, there's an algebraic path. We're going to talk about that for sure. But on many of these questions, I think it's the case here. Especially, this is like a factoring question. You know what I'm saying? Like, they want you to factor this expression, and then once you factor, you can kind of solve for Z. On the original SAT, like practice tests 1 through 10, if it's a factoring question, the right answer is always a single-digit number between 0 and 5. Always. If it's a factoring question, which makes a ton of sense, because if x is like 17 or like 43, like the factoring is just going to be way too complicated. So the answer is that the values tend to be smaller. So on the old SAT, I always recommend students just start plugging in numbers between 0 and 5 and see what gives us the true statement. Does that make some sense?
Yeah.
I want to start there because I think it's going to work here. Would 0 give us a true statement here, Tanner?
No.
No, it wouldn't. We'd get negative 24 on the left-hand side. Would 1 give us a true statement here?
No.
No, I don't think so. We'd get 1 plus 10, that's 11. 11, no, that's not going to work. What about 2? Would 2 give us a true statement here?
No.
Why not?
It's going to end up being a negative number.
I don't think so. I want to see you plug in a 2 because I'm pretty sure 2 works. Let me see you plug in a 2 for z into this equation. I could be wrong here. I haven't looked at the answer.
Oh, wait. No, it's going to be 56. But...
Well, let me see you plug in a 2 for z. Are you doing it on the way? There we go.
Multiplied by 2 minus 24. We have 4 plus...
Looking good.
20 minus 20.
Oh. What's 4 plus 20?
24.
What's 24 minus 24?
There.
There's your answer.
Goodness.
2 works. 2's an answer. Does that make sense?
Yeah.
Yeah. So I'd look for that path if it's a factoring question. See if you can plug in values between 0 and 5. It works on the old SAT, works on this question. I haven't gone through all of the new digital SAT questions, but I would expect it to be single-digit numbers for the same reason. I think I've seen one exception to that, like on another SAT, but most of the time it's the case, so give that a shot. Let's talk about factoring, though, because sometimes you do have to, rarely, but sometimes you do have to factor. Do you know how to factor the expression in the question here? Do you have an idea how to do that, what that means?
It's been a while since I've factored.
Let's go over it. So we know we got two terms here, sort of multiplied in parentheses. When we multiply this together, we're going to get 0. Okay. And have you ever foiled before? Do you know what foiling means?
I don't think so.
No. I want to go to the rules document real quick. I'm guessing you've seen this before. I think most students have seen this at some point. This is toward the end of the rules here. This might be one of my... Yeah, it's basic concept T. Basic concept T is the FOIL method. Okay, check that out.
Okay.
Do you have that in front of
you? Yeah.
Okay. So FOIL, it's an acronym. It stands for first, outer, inner, last. Okay. When you're multiplying polynomials, basically you just multiply the first terms. Those are the ones in blue right here. Okay. And then you multiply the outer terms. Then you multiply the inner terms. Then you multiply the last terms. Basically, you multiply each term by each term, at some point, and then combining like terms. Okay. Is that somewhat familiar? Have you seen that before? Maybe you just haven't heard the term FOIL.
Yeah, I've seen it before.
Yeah, you've seen that before. So let's go back to the question. Because we know, well, first of all, we know when we multiply the first terms, we're going to get z squared. So our first terms have to be z right here. Does that make sense why our first terms have to be z?
Yeah.
And then we're going to have like plus or minus something here in these spaces. Now, when we multiply the last terms using the FOIL method, we know we're going to get negative 24, right? Because these two terms here, the last terms multiplied, there's no z there. Right, it's the only terms that aren't going to give us a z when we multiply them together of any sort. We're not going to z squared or z. So multiplied together, we get negative 24. But added together, those terms are going to give us 10. Okay, so multiplied together, we get negative 24. Added together, we get 10. Can you think of some values that multiplied together, we get negative 24, and added together, we get 10? One of them is going to have to be negative.
Yeah.
Right? Because we're getting negative 24 and we multiply them.
3, 2.
One way to do it is just break up negative 24 into
I got
its
one.
factors. Oh, you got one?
Yeah.
What is it?
One would be -2 and one would be 12.
Yeah, negative 2 and 12 should work. Because you multiply those together, you get -24, and then added together, we get 10. So that should work beautifully. If you're unsure about how to do that, just break up -24 and its factors. You know, -6 and 4 would work as well, but added together, you don't get 10. -1 and 24 would work as well, but again, added together, you don't get 10. So, but -2 and 12 do work. So we know it's z minus 2 and z plus 12. Those are your factors. Does that make some sense how you can break it apart like that?
Yeah.
Yeah. Once you've got that, you should be able to look at this and see what your two solutions are for z. One of them, obviously, is 2, which is what we got, right? Because when you plug in a 2 for z there, you get 0 times, z minus, you get 0 times z, 0 times this thing, which would be 14, I guess. So that's going to be 0. What's the other answer they would take here? And you can find that answer for z, the other solution, by looking at that factor. What value for z would give you a 0, basically, in parentheses there?
0 parentheses. 0? No, sorry.
Yeah, I mean, you're going to want the stuff in parentheses to equal 0. So the question is, what value of z gives you a 0 there?
Something minus itself, or?
Yeah. It would be -12.
Okay.
-12. Does that make some sense? Why that would work as well?
Oh, yeah. Yeah.
Yeah, it's -12. So that's an option too. So you can factor if you want to. But again, here, just plugging in values works beautifully. And the right answer is a single-digit number between 0 and 5. Questions about that?
No.
Okay, great. Okay, let's try number 15 here. Increase the size here and go ahead and read question number 15 for us, please, when you see that.
Bacteria are growing in a liquid growth medium. There are 300,000 cells per milliliter during initial. Words are hard. Initial observation. The number of cells per milliliter doubles every 3 hours. How many cells per milliliter will there be in 15 hours after the initial observation?
Oh, man, there's a lot going on here. What are we solving for here, Tanner, with this question?
How many cells per milliliter will there be in 15 hours?
In 15 hours. Yeah. And we know, I guess we're starting with 300,000 cells, right? During an initial observation. Let's talk about that word initial. What does the word initial mean?
The first.
Yeah, to start with. Yeah, exactly. So we're starting with 300,000, and then it says the number of cells per milliliter doubles every 3 hours. It doubles every 3 hours. Okay. Now, the temptation for a lot of students is like, they just start messing with numbers and like, I'll just start dividing by 3 or dividing by 15 or like just start doing stuff with numbers. Don't do that. Avoid that temptation. Let's just think clearly about the situation. Okay? Because we know, we're trying to figure out how many cells there will be in 15 hours. We know we're starting with 300,000. I know how many cells there's going to be in 3 hours.
Mm-hmm.
And so do you. How many cells are there going to be in 3 hours?
600,000.
Yeah, 600,000. It's just doubling because they tell us that. Does that make sense? How you can just sort of logically figure that out without doing some fancy operation? Okay. Now we know how many cells there's going to be in 6 hours, right? Because that's another 3 hours, right? Does that make sense?
Yeah.
Yeah. How many cells are going to be in 6 hours?
6 hours, double that. 1,200,000.
Yeah, 1,200,000. Absolutely. You see where this is going?
Yeah.
Like, let's just follow this path here, this logical path, and work our way up to 15. What's the next number of hours?
12.
Well, I wouldn't jump up to 12.
No. Yeah.
Right? Let's go up by 3 hours at a time. right? Because it's doubling every 3
9.
hours. Let's do 9.
Yeah, 9.
Yeah, does that make sense?
Yeah.
Okay. How many 9 hours?
2,400,000.
2,400,000. Okay. Okay. What about, let's do another 3 hours. That'd be 12 hours now.
Mhm.
How many cells?
4,800,000.
4,800,000. I think we already know the right. We already know the right answer, by the way. What's the right answer have to be?
9 million.
Yeah, it's got to be D, right? I mean, we double it again, yeah, because that's gonna. But like nothing else is right. Yeah, the others are already too small. But yeah, we can double that 4,800,000 again. We'll get 9,600,000.
Yeah.
Does that make sense? How you can find the right answer? Sort of just like working your way through it, thinking about it clearly without doing a fancy operation.
Yeah.
Yeah. Yeah. I mean, another way to do it is to recognize it's going through, I guess it's going through like 5 doublings. Does that make sense?
Yeah.
It is. So like if you want to sort of like set up an expression, you could. It would be like 300,000 times, and it's doubling, so it's 2 to the power of 5. That should work. I think that works. Let me double check that real quick. I'm not certain. Let me see. 2 to the power of 5 times 300,000. Oh yeah, that works. Yeah. Does that make a little bit of sense why that expression would work?
Yeah.
But setting that up isn't super obvious. I don't think it is. And I think a better path is just logicking your way through it. Doesn't take too long to realize that the other answer choices are just way too small. But I love using that logical sort of approach. Works on so many questions. So think less about doing operations and think more about understanding things, and let that understanding guide your steps. Questions about that?
No.
All right, great job there. Great job. And that's why we were talking a little bit before the recording. And he's in Algebra 1 right now, which is interesting. So you haven't even taken Algebra 2 yet, but like, is there any question we've gone over so far that's sort of beyond your skill set? Tanner?
Not really.
Not really. Not really. These are all questions you can do. It's just not the math isn't that advanced. It's not. It's just thinking clearly about it is the key. Go and read question number 16 for us, and we'll discuss.
Which expression is equivalent to 6x to the 8th power multiplied by y to the 2nd power plus 12 multiplied by x to the 2nd power multiplied by y second?
Yeah, absolutely. Woo! Let's talk about some of this vocabulary here. First, what does the word equivalent mean? Have you heard that before?
Equal to.
It just means equal to. Yeah, that's all that means there. So we got to find the answer choice that's equal to or equivalent to this big messy expression here in the question. Okay. We got a couple options here, Tanner. We got a couple options. We can sort of factor this expression here, kind of break that into its factors. We could also maybe just like take the answer choice and sort of multiply all those out. You know, maybe like distribute these terms here in C and D, multiply stuff in A and B, see if that equals that. Do you know? There's also a way to plug in values here, which is actually a good place to start. Would you feel comfortable sort of factoring out some terms here? What are your thoughts at the moment?
I'm just my initial thought process is looking at the answers and kind of seeing similarities between them. Yeah.
Here's where I want to start. Because I don't think the operations are obvious to a lot of students.
Yeah.
Let's start by plugging in values. On most of these equivalent expression questions, you can just plug in a value, like create values for x and y. We'll plug in those values into this expression, find out what that equals for those values of x and y.
Mm-hmm.
And then if we plug those same values of x and y into the answer choices, the right answer has to match up with the value of the expression of the question, if it's equivalent or equal to it. Does that make some sense, why that's going to work?
Yeah.
So let's do that. I want to start there. I don't know if it's going to be enough to get us the right answer, but we can start getting rid of some bad answer choices. I'm going to make x equal 1. I'm going to make y equal 1. Okay, ones and zeros are great when you're plugging in values. They just make the arithmetic really, really easy. It's not always the best values to plug in. I think we saw like one of the questions we were plugging in like a 5 for t, or another question we were plugging in bigger values as well. Depending on the question, it might make sense to plug in different values. But here, starting with 1 and 1 works great. So do you know what this expression here in the question equals when x is 1 and y is 1?
Yeah.
What does that equal?
Quick math.
I mean, if you want to work it on the whiteboard, you can.
Yeah.
Here's a question for you before you work it out. What's 1 to the power of 8 equal?
8.
No.
Oh.
I'm gonna plug in these x and y values real quick because I want to make it really clear how these exponents work.
Oh, it's 1. Sorry.
Yes. Do you see it now? And if we put in a 1 for x and a 1 for y, we're gonna get this statement.
Yeah. So it's gonna be 12.
Yeah, so it's gonna be 12 plus 6, right? Basically, like all of these terms here with 1 to the power of 8 is 1, 1 squared is 1. 1 times itself is just 1.
Yeah. Took me a second, but yeah 8.
It's gonna be 18. Does that make sense, Tanner?
Yeah.
Yeah. That's why I like plugging in ones here. It's basically like all the terms with variables sort of like disappear. Essentially, we're left with just the coefficients in front of the variables. It's just 6 plus 12. Okay. So the right answer has to give us 18 when x is 1 and y is 1. Does that make sense?
Yeah.
Okay. So let's plug those into the answer choices. What does answer choice A give us when x is 1 and y is 1? And it's the same thing here. All the stuff with x and y's.
Yeah.
Essentially, it's going to 1.
Go to 12.
It's going to be 12, not 18. So it's not A.
Yeah.
What about answer choice B?
It's going to be 6.
It's going to be 6. We're looking for 18. It's not B. What about answer choice C?
C is going to be 14.
Double check that.
Wait. 6. 1. 15.
Let's start with this part of the. It's not 15. Let's start with that part of the expression. If x is 1, what's the stuff in parentheses going to be?
3.
It's going to be 3 because we're going to get 1 plus 2. Does that make sense?
Yeah.
And then what's this stuff going to equal here if x is 1 and y is 1?
6.
6. So it's just going to be 6 times 3. Does that make sense?
Yeah.
So what's that equal?
18.
18. What about answer choice D? What's that going to
D is going to equal 18.
It's going to equal 18 as well. Ooh.
Ooh.
So it could be C or D.
Yeah.
Does that make sense?
Mm-hmm.
Yeah. I love plugging values. Again, if this is as far as you get, you've got a 50-50 chance if you can keep your arithmetic straight. And those are good odds on a tough question, especially if you don't know how to do this algebraically. I'd rather have you guess between 2 possible answers than guess between 4 possible answers. Okay.
Yeah.
So let's kind of talk about the properties of exponents now, because we're going to have to do some algebra here. I'm going to clear some space on the screen. If it's between C and D, again, I don't recommend trying to factor the expression in the question. I think that's just a trickier path. But let's think in terms of like multiplying out C and D. Like we can distribute the 6x squared times y squared to these terms here in parentheses. You're familiar with the distributive property?
Yeah.
Yeah. So we can multiply all that out and see what we get. We'll see if that gives us the expression in the question. Do you think you know how to do that if we have to multiply those terms? You can say no if you don't.
Sorry, you were cutting out.
Yeah.
Can you repeat the
Do you know how to multiply those terms? Like, do you know how to multiply 6x squared times y squared times x squared? Do you know how to multiply those terms?
Yeah.
Let's do it. Let's see what we get.
So we're multiplying 6 into both of these, making sure, right?
Yeah, multiplying 6x squared y squared times x to the power of 6, and then multiplying that by 2 as well. Mm-hmm.
So we would have 6 on the other side. But 6 multiplied by 1x is 6x, and we still have that 2 to second on top, plus...
Well, hold on just a second. I'm a little bit confused what you're doing here, actually.
I was multiplying into both of them. Like,
yeah. So let me show you how I would describe it. I just describe it like this. We'll get 6x squared, y squared, times x to the power of 6 when you're multiplying these two terms. Does that make sense?
Yeah.
That's all it is to start. And then we also have to multiply that by the 2.
Mm-hmm.
So distributive property we're adding here. Plus, and then 6 times 2 is 12. So that gives us 12 x squared y squared. Because you're just multiplying the 2 and the 6 there. Does that make a little bit of sense or not so much?
Yeah.
Okay. Again, just distributive property. But this is a little tricky here because a lot of students will look at this and be like, oh, I don't know what to do with those exponents. I've got an x squared and an x to the power of 6. And I was like, what do you do with that? You know? But here's how I recommend thinking about it. How many times are we multiplying x in this term right here that I just circled? How many times are we multiplying x?
Multiply by x is 2 times.
Well, why do you say 2? Oh, because we've got x squared and x to the power of 6. Is that right? What does x squared mean? Let's start with that.
X squared is 1 to the power of 2, right? Which is 1.
Well, right now, don't worry about like x being 1 and y being 1. Don't worry about that. Maybe that's kind of where the last part you were thinking in terms of x being 1 and y is 1. But we're dropping that for right now. I'm thinking about this algebraically. But x squared in general, let me make it real clear. X squared just means x times x. Does that make sense? I mean, if you're squaring something, it means you're multiplying by itself. What does x to the power of 6 mean?
It means you're multiplying x by x 6 times.
Yeah, you're multiplying x by itself 6 times. So x squared times x to the power of 6 is x times x times x times x times x times x times x 6 times. Is that 6 x's there? Yes, it is. Okay?
Yeah.
Multiplying these two terms is the same as doing this. Does that make sense, Tanner?
Yeah.
Okay, good. What does this thing equal? This guy right here. What's that equal? We can simplify that.
Simplifying the...
Yeah, we've got x multiplied by itself 8 times. How would we express that? And simplify that.
X to the 8th power.
X to the 8th power. Because that means you're multiplying x by itself 8 times, which is what's happening there.
Yeah.
Does that make sense? How you can kind of figure out what the operation is if you understand what the notation means?
Yeah.
Once again, yeah. Think in those terms. I mean, there is an operation here. Technically, when you have the same base and different exponents, you can add the exponents if you're multiplying those terms. So here it's just 2 plus 6, right? Which gives you 8. So it's x to the power of 8. That's the operation. But I should recommend focusing on what the notation means. Some students are like, oh, do I multiply those? Do I add those? And they forget what to do or they take a guess. But you don't need to. You can figure it out if you understand what the notation means. Does that make sense?
Yeah.
Okay, good. All right, so that's just going to equal, combining those terms, we're going to get 6 times x to the power of 8, and then the y stays the same. It's y squared. Does that make sense? And then there's nothing else to do on the right-hand side of the expression. Oh, looky at that. I think that gives us the expression of the question.
Yeah.
Does that make some sense?
Yeah, it does.
Yeah. Let's practice. So C is looking good. I'm going to double check here. 16 is C. I want to double check answer choice D, and I want to test that one by multiplying that out. And I just want to show you why it's not right. Do you think you could multiply out answer choice D?
Yeah.
Yeah, let me see you do that on the whiteboard.
With all that simplifying. Wait, were we doing the
we're doing answer choice D. Yeah,
okay.
you can. If you just know how to simplify, you can simplify it right off the bat. I just want to see what we
do. Which is 6x.
Yeah, there's 6 X's altogether now.
Yeah.
Exactly right. Once you kind of see it the right way, I'm just going to
2.
make that really clear that that's a 6.
Yeah.
I got you.
And y stays the same, and then you have the +2 on that side.
Yeah.
Yeah.
So then that would be +12. Because you're multiplying the 2 and the 6.
Oh, yeah.
So x squared, y squared. Does that make some sense? Yeah. So I mean, you do have to be familiar with properties of exponents here to determine between C and D. If you're moving beyond plugging in values. But does that property make sense of the exponents there? Yeah. Tough question, right? It's a lot to process visually. I think that kind of makes it a little bit tricky. But I think the more you focus on what the notation means, the better. Questions about that, Tanner?
No.
Okay. We got a little more time left. Let's do some more. I don't think we're going to get to all 27 here at the moment, but let's keep working. All right, go ahead and read question number 17 when you see that up on the screen.
Yeah, just adjust it a little bit. A neighborhood consists of a 2-acre park and a 35-acre residential area. The total number of trees in the neighborhood is 3,934. The equation 2x plus 35y equals 3,934 represents the situation. Which of the following is the best interpretation of x in this context?
What are we solving for here, Tanner?
Trying to find the best interpretation of x.
Yeah, the best interpretation of x. Yeah. Now, this is a tough question. We've done a number of questions where they kind of give us a situation, and then we've got to develop the equation or the inequality based on the situation. You know what I'm saying?
Yeah.
And then this is kind of the opposite perspective. They give you the equation, and we've got to figure out what the situation is.
Yeah.
It's sort of the opposite perspective of that. So this is a tricky question. It really is. First of all, we're trying to figure out the best interpretation of the value of x in the equation. Let's look at the equation a little more closely. Notice the equation here, we're multiplying 2 times x.
Yeah.
Multiplying 2 times x. So whatever x is, we've got to be multiplying that by 2. Well, what's the value sort of in the situation that involves a 2?
The first thing that jumps out to me is they have the total number of trees in the area at the end of the equation.
Yes. So that's important to note as well.
This is letting me know that whatever x is, that's going to give me the total number of trees in the 2-acre park. And that's what we're solving for.
Yeah, when we multiply it by 2.
Yeah.
Right? Exactly. You're absolutely thinking along the right terms, right? So that's definitely involving, the x is involving the 2-hectare park. It's not an acre. I don't know, a hectare is bigger than an acre, I guess. I don't know. But it's an area thing. Yeah. And then we could probably figure out what the y value is, right? Mm-hmm. What's the y value probably? It's because we're multiplying that by 35. So what's the y value probably?
It's going to be the number of trees in the residential area of the 35 acres.
Yeah, it's probably have something to do with the 35-hectare residential area.
Mm-hmm.
So we're trying to figure out what x is, but that's relating to the park, right? Right?
Yeah.
Because that's where we're multiplying by 2. So I think we can get rid of any answer. We're going to test these answers here, but I think we can get rid of anything that's not involving the park because the x here is being multiplied by the 2 value. There you go. I love it. I love the way you're thinking about it, right? All the stuff with the residential area is gone. And that's all we've done there is just realize that we're multiplying the x by 2, so we're dealing with the park. And if this is as far as we get, we've got a 50-50 chance now. Does that make sense, Tanner?
Mm-hmm.
Listen, I can't guarantee much in life for you, Tanner, but I can pretty much guarantee you're going to see some questions on the SAT that you're not going to know exactly how to solve. I see some still, including on the new test where I'm like, I'm not quite certain how to solve that one. But you're playing the game the right way if you can just find ways to dramatically increase your chances of guessing well. So I'm cool with that if this is as far as you get. But let's break it down between A and C here. Answer choice A says the average number of trees per hectare in the park. Could that be the interpretation of the value x, the average number of trees per hectare?
Well, I think it's C in my opinion, because we're we're looking at the total number, not the average number.
Well, hold on. Don't we know the total? Oh, the total number of trees in the park. I see what you're saying.
Yeah.
Yeah. Well, if this is tricky here. A says the average number of trees per hectare, because I'm leaning toward A right now. I'm not looking at the answer just yet, but I'm leaning toward A. And the reason why I am is if we know the average number of trees per hectare, we should be able to multiply that by 2 and get the total number in the park.
Yeah.
Does that make some sense?
Yeah.
Yeah. Because like if there's like 100 trees per hectare, then the park has 200 trees. Does that make sense? You can start thinking in terms of like plugging in values here. So I think A would work. But if the total number of trees in the park is X, if we multiply that by 2, we're going to get double the number of trees in the park. Does that make some sense? So that's why I think it's probably A and not C. Let me double check the answers here. For number 17. Yeah, it's A. It's A.
Okay.
Yeah. Does that make sense there?
Yeah.
Yeah. And again, it doesn't bother me getting a question like this wrong. It's not a great, it's just, it's not a great way to like, there's no operation here. It's just, again, understanding what things mean. But when we were deciding between A and C, there was still a way to sort of plug in values, create a value for the average number of trees per hectare and see if that makes sense. It does if you plug that in. But it doesn't make sense if X is the total number of trees in the park. It doesn't make sense if the average, if the total number of trees in the park is 100 and you plug that in, you're going to double that number. That's not what we're doing here. Make sense?
Yeah.
That's tricky. This is one that made me think. I just, I didn't, the right answer was not obvious, but I knew it was between A and C at the very least. So think in those terms, focus on elimination on this test, right? You may not always know exactly what the right answer is, but if you can figure out what the right answer is not, you're on the right path.
Yeah.
All right. So question number 18. Ooh. I'm going to zoom in a little bit here. All right, go ahead and read question number 18.
Yeah.
Can you see that on your screen?
Yeah, I'm just adjusting it. The graph shows the relationship between the number of shares of stock in a company, A, X, and the number of shares in a stock for company B, Y, that someone can purchase.
I think it would be Simone. I think it's a name, right? Oh. It doesn't matter that much here, but yeah, words. But anyway, you got it.
Which equation could represent this relationship?
What are we solving for here?
We are solving for the relationship between the two different companies.
Yeah, between the two different stocks of these different companies. And that's a fancy way, by the way, if they're saying, what's the relationship? That's a fancy way of saying, what's the equation of the line? That's all it means. Does that make sense when they say, what's the relationship between these variables?
Yeah.
What's the equation? Because that's all an equation does, by the way. It represents the relationships between values, known or unknown. That's all it does. So what's the equation? We got a couple options here. Okay, we can think in terms of like slope and y-intercept. It's not a bad way to do it, although some of these answers aren't in that y equals mx plus b form, like b and d aren't in y equals mx plus b form. So we'd have to like do some algebra to put those in y equals mx plus b form, and I don't know. If we can avoid that, I'd rather avoid it. There's a better path here on this question to find out what the right answer is. And you can do this pretty much any time they give you a line and there's like, what's the equation for the line? We can pick values from the line and plug those into the right answer. We'll plug them into all the answer choices. But the right answer has to give us a true statement for some values that we pick from the graph of the line. Does that make sense why that has to work?
Yeah.
Yeah. Here's the first value I want to pick. This guy right here. What are my x and y values at that point?
X value is 60 and 0.
60 comma 0, right? That's exactly what that is. We know for the right answer, when the x value is 60, the y value has to be 0. Does that make sense?
Yeah.
Yeah. We could pick other points as well. We could do like, there's a point right here. I think that would be the point 30 comma 20. We could do that as well, but I think the arithmetic is going to be real easy. We just start with 60 comma 0. So we know when the x value is 60, the y value has to be 0. So let's plug those in to the answer choices and see what answer choices give us a true statement. Look at answer choice A. Does answer choice A give us a true statement for those values?
No.
No, it doesn't. What about answer choice B? You can use that calculator. Probably going to want to.
Yeah. 1 second.
Yeah, test it.
8.
I'm doing the same.
6. Yes.
It does, doesn't it? Right? Because we get 480 plus 0 equals 480. That's true. Keep it. I don't know if it's the right answer yet, but we're going to keep it.
Mm-hmm.
What about answer choice C? What's that give us?
C 0.
Yeah, because that can be a true statement.
Multiplied by 60. No.
No, doesn't give us a true statement. What about answer choice D?
No.
Definitely. No. Yeah, we get 12 times 6 is too big. Yep. It's B.
Yep.
Woo! That's not bad, is it?
No.
It's not, if you can find ways to plug in those values. And so look out for that. If they give you a line and they're like, hey, what's the equation? Man, I mean, you can sometimes think in y equals mx plus b terms. You can. But here again, answer choice B, the right answer isn't in y equals mx plus b form. So you're better off just plugging in values. It should also work with this point here. You could do 0, 40, right? When x is 0, the y value is 40. That should work as well. I mean, it has to for the right answer. But just plug in that first set of values, 60, 0, that gives us the right answer. No problem. Questions about that?
No.
Look for ways to plug in values. It is the best strategy, the best hack for the SAT. It's fast and accurate.